I want to talk about the shapes in a tangram tile and the relationships to each other. There's a lot that can be said about these, and I'm just going to say some things. First thing is, the tangram tile is a square. And if I turn the tangram tile like this, it's still a square. So that's just how I want to start. I'm actually going to start by talking about that square and end by talking about this square. At least I think that's how it's going to go. Okay. I'm also going to use this 4-inch square to make the tiles, and so that you can see how you can make your own tiles out of any 4-inch square or any square at all. And the way I'm going to start is I'm going to start by making these two large triangles. You can see that there's a diagonal running between them from corner to corner of the square. So I'm just going to fold this in half. I could have drawn that with a line and a pencil and cut it with a scissors, but I'm going to use this little tool to do that. Okay, so this part I'm not going to be using right now, and this I've created a shape for both of these squares, but I still need to fold this in half and cut it. Okay, so now I've got these two shapes. A couple of things I wanted you to see about this. First of all, since I folded it in half, there was one right on top of the other. They were exactly the same. These are called congruent shapes. So the con in congruent means together. The ruent means something like rush. So they're sort of rushing to agree with each other. And you can see that they agree with each other exactly. Okay. The other thing that's kind of interesting is that before I cut it, it was the corner of a square, right? And now it's not the corner of a square anymore. It's two different ones, but there is still another corner of a square here, and it's right down here and here. There's two of them. Look. They fit exactly the corner of a square. And so that's a 90-degree angle. It's the corner of a square. We call it a right angle, and because this triangle has a right angle in it, we call it a right triangle. But there's even more to it than that. This is an isosceles right triangle. And the reason it's called isosceles is because it's got these two equal legs. Do you see? It's a pair of equal legs, just like you. You've got a pair of equal legs. So you're an isosceles. You're not an isosceles right triangle because you don't have a right angle there, but you're isosceles. And isos means equal, and skelos means leg, so it's like equal legs. Okay, so we've got congruent isosceles. We've got congruent isosceles right triangles here. Now, this was kind of odd to see the square in the middle of a shape. Usually, we think of a square angle as being the corner of a square. And that can easily be achieved by taking this, turning it around, and boom, there's our square. Okay, we've got them on opposite sides of each other. And look, that corner still fits in our square. So that's also now a 90-degree angle when they're together. Okay, so let's put these aside for now and look at what we've got over here. This is what we have left. I'm going to make this next piece, this little triangle, next. And you can see right away it's got the corner of a square. So there's another, you can see the little square here. It's another right triangle. And it appears to have also equal legs. So we have another isosceles right triangle here. There's something interesting that goes on when I go to create this. So we've got the triangle. And what I'm going to do is I'm going to bring this top vertices right down to the base, straight down. And a couple of interesting things happen here when I do that. One is it looks like I've got 3 triangles now. 1, 2, 3, although this one's upside down, and compared to these, and they all look the same. And in fact, they are all the same. We also have sort of created another shape, which is a trapezoid. And a trapezoid is a shape that has a set of parallel lines. A set, right? Top and bottom, that's 2. I like to think of a trapezoid, no matter what the sides look like, as a triangle that has a triangle that's been caught in a trap and it's separated its top from its bottom. Okay, so here's just sort of a kind of a random triangle, right? And it gets caught in a trap, and now we've got a trapezoid at the bottom because it has a pair of parallel lines. That's the trapezoid. Okay, but I wanted you to see that because it's kind of embedded in the shape. It's kind of embedded in this tangram, but we're not going to be using it right now. We're going to be looking at this piece that I just cut off. Okay, it has that square corner, and it looks an awful lot like the one we just had. Now, this is something interesting. People will often look at this and they know that that's a right triangle because it's in this position. But sometimes when it's in this position, people won't recognize it as a right triangle. It's still a right triangle. Rotating a shape doesn't change what it is. But since we're used to seeing right triangles as corners, don't be fooled. Remember, right triangle, it has a right angle in it, it's a right triangle. And these also these have equal, this has a set of equal legs, just like this one, but they're definitely different sizes, right? But you can see the angles are equal by moving that around. I'm going to use a different color just to make it clearer. See, the angles are equal. You can see that just by moving it around. Because these have equal angles, there's 3 equal angles on these triangles. We call these similar. Let's see, I've got a similar, I think that says similar somewhere. Here it is, on the back of my trapezoid. So they're similar, and what a similar triangles are, or what similar shapes are they're scaled versions of the other. Scaled meaning this is scaled down to be smaller, or this one is scaled up to be larger. But they're scaled versions of each other. So these are similar. And now we've got these similar shapes that make sort of an interesting things going on. Okay. Put them in a line, they look like this. Okay, so let's put these aside now and go over to here. Okay, so this is our trapezoid again. This is our trapezoid, and because it's got a set of parallel lines, but as you can see, there is no single trapezoid in our tangram, but there is a line that divides these 2 sides in half. Okay, so I'm going to fold this in half, cut it. And actually, what I have here are 2 more trapezoids, because you can see that if I made if I extended these lines, it would be a triangle that got caught in a trap and separated its top from its bottom. Okay. but that's not the shape we're looking for. We're looking for a triangle and a square. So let's do that with this one. The way I'm going to do that is, I think this one I'm going to use the scissors for, because what I want to do is, I'm going to use this as a guide. I'm going to meet right here at the top of that triangle and line this up so this bottom is straight across. There's my line, and I'm going to cut that. Boom. We've got our triangle and our square. Oh, look at this triangle. Is it a right triangle? It was like this on our tile. And is that a right triangle? Well, it sure is. There's our right angle. Is it the same size as the one we had before? No, it's not. So we have this nice little progression of triangles. Okay. Oh, it looks like the side of this one matches up with the side of the bigger one. I wonder if the side of this little one is going to match up with the one that's right below it. Yes, it does. Look at that. So there's a relationship between these. Okay, let's put these aside. We're going to talk about the square later. And we've got this last piece. Now, if you're cutting these, you're going to have to be careful. I keep making a mistake with this. Okay, I'm going to put it like it's pointing to the right. Okay? It's pointing to the right, and I want to get this triangle in this corner so that I've got a line that's parallel with this line on the right. So that's something to keep in mind. So it's somewhere around here. Okay? And I can use my square right here, my little triangle right here to help me find that place. So I'm going to line that up just perfectly. You'll see that the point of this triangle right here would line up with this vertices down here. So there we go. I'm going to make the cut, make the line, and then I'll make the cut. And I've got my triangle. And look, these two are exactly the same. Okay? So, look at this. These two are exactly the same. And I'm going to, just so that you can see this better, I've got this other triangle that's congruent with the one below it. And look, I can move this around so you can see that these two can fit just right into the one behind it. Okay? Oh look, you can make another shape from it by lining up those edges. There's a rectangle. Okay, so let's see what else we've got here. So now we've got this shape that we haven't talked about yet. Here it is over here. It's a funny shape because it's not one that you see all the time. Okay, and I'm going to call this could be called a quadrilateral because it's got four, which is quadrilateral sides, 4 sides, but it's got 2 sets of parallel lines. So we call that a parallelogram. Okay, and it's an interesting shape, but look what it's made out of. I'm going to take a different parallelogram, and I'll just turn it over like this so they're the same. And I'm going to show you that it's made up of these 2 triangles. There we go. All right. So that's kind of nice to know. The last shape that we have in our little group is the square, and let's see if these have a relationship to the square, these little ones. Looks like it. Maybe looks like it. And probably my cutting is just a little bit off, but yeah, these are the same size as the square, or at least they should be. There we go. You can see that the edges are all the same size as the square's edges. Okay, oh, and look what happened when I put those two little ones together with the square. It made another triangle. Is that the same as this one? Let's see. Oh my gosh, it is. It's the same as that one. So you've got all these different relationships going on. The last thing I want to show you, and there's a lot more relationships in here that you can see, but these are just a few that I want to show you. So here's the size square that we started with. If I take these and make them into a square, it's smaller than the square, but it doesn't sort of fit in just right unless I turn it over. Look, I'm putting it like this. So I think I'll turn these over so there's not so much going on. Look, it goes right to the edge of the square that of the original size square. I'm going to put a little tape on here just to keep it from moving around so I can show you what I'm doing here. Okay, so then we had these little pieces, right? These are all the same as what we've cut out. I just want to use different colors so you can see them better. And if I take these and make a square out of them, which I can, let's see. There we go. There's a square, right? If I put this in here, look. These fit right inside of the square below it, but at a diagonal, right? And what's also interesting, I'm going to put it like this. What's also interesting is now this inner square is exactly half, the sides are exactly half of the large outer square. See that? Exactly half. But they fit inside this other square at a diagonal. There we go. Okay, stay there. And then I want to show you one more thing, because we have that little square. I'm going to tape that there so it won't move around. So we have that final square, and look, this fits in also in that rotated way to this one below it. And not only that, but its edges are exactly half of the one that's a layer below the one that it's above, this one. See that? So those are some pretty interesting relationships. I had said that there was no trapezoid in our tile, but remember, you can make your trapezoid by recreating the shapes. Let's see, we needed a square, a triangle, another little triangle, and I'm going to have to turn this over, and there's our trapezoid. Okay. Oh, look, there's also a trapezoid. Oh, look, there's also a trapezoid. See, it's got a trapezoid because it's got a set of parallel lines. Okay, there's a lot more to see in these relationships, but thought that this would be a nice way to get you thinking about that, and to also become aware of some names if you're not fluent with them. Remember, we've got, if they're exactly the same, they rush to agree, they're congruent. If they've got a right angle and they've got equal legs, it's an isosceles right triangle. There's the parallelogram, which is this one. Two sets of parallel lines. Similar shapes are scaled versions of the other. And so I hope you saw how I sort of drew out the lines to make these shapes, because if you did, what you can do is you can take cards, cut them into shapes, cut them into your tangram shapes, and then put them back together again in a different way. This one is made with a holiday card. This one's made of a drawing of mine. This one's made with a holiday card with a different card with it, and this is made with 3 different cards. See? And put them all back together and create kind of fun arrangements. And it's harder to put this back together than it may seem, but yeah, have fun with that. Bye.